Hi everyone, thank you for joining today's online guest lecture. Today we will learn about data mining itself, and it is my pleasure to introduce our guest speaker, Professor Lau from the Department of Smart Computing and Cyber Resilience, School of Computing and Artificial Intelligence, Sunway University. So, Prof. Lau holds a bachelor degree from University Malaysia and complete both his master's and doctor of engineering at Universitat Kassel in Germany. His research cover computing, smart cities, applied machine learning. So I do believe that we have a lot of new knowledge from Prof. Lau itself. We are very honored to have him with us today. So, ladies and gentlemen, please welcome Prof. Sian Lun Lau. Prof. Lau, we kindly invite you to begin your presentation.
Yeah, hi. Selamat pagi, everyone, and nice to see you online. I can see there are 90 over people here, so that's pretty scary with so many people. Thank you for the introduction. Can I just share the slides directly?
Sorry?
Yeah, I'll just share the screen, right, for the lecture.
Yeah, you can share, Prof. Sorry, Prof. We cannot hear your voice.
The audio, is it working?
Yeah, it's audible now, Prof.
How about now?
Yeah, so clear.
No, it's okay. All right. Good. And if you can see the PowerPoint, just put a thumbs up or do something on your smiley, then I can see it on the screen. And for everyone, if you are not too hungry yet, put +1 in the chat, then I will know everything is really working. Okay, there's no +1 in the chat, so I assume no one is hungry. Okay, thanks for the introduction. I'm Sian Lun. I'm from Sunway University, and in the next 1 hour and a half, I think that's the time given to me, I'll try to run through a introduction to clustering within the context, right, of data mining. I understand this is also for students who are taking the subject data mining, and it's somewhere in the middle of your semester. Therefore, let's look into something I find very interesting about this thing called clustering. If I'm too fast, just get my attention. Typing in the chat, I can see the chat window myself, or wave quickly. Turning on your camera, I'll see it. So the outline, I think, is kind of how I plan the content, and hopefully the last few things from practical application onwards. If I'm, short of time, I may go a bit faster. But the good news is the slides and also a sample code I've uploaded in Google Drive. So if you follow this link, I'll also post in the chat. You can actually download, and try it out yourself later. I have tested them. They should be correct. And a disclaimer, quite some of the content are AI generated, but checked by me. So at least, they are not content that are wrong to my best effort. Okay, so I think that's, again, something just to make sure you're aware of. So to this topic, I've set some learning objectives so that you know what you should get, right? After this class, if you go home, and your grandmother asks you, what have you heard today from this funny old man from Malaysia? You can say, I know this thing called clustering, and I can explain to you why this is important. You can tell how many types of major, I would say, classic clustering approaches, and also you can differentiate them And I'll give you some examples with code that you can try to see how K-means clustering works. And we talk a little bit, if there's time, how you can evaluate, because being able to do machine learning, data mining, but not understanding how to know what is working or not, I think that's where evaluation comes in quite importantly for all of you. And maybe some of the examples I give, we think it may fit into the Indonesian context, and I hope that is something you can relate, how maybe the next problem you see when you go out to the town, when you face different situations in your daily lives, you can actually apply some of this technique to see how they can help you to solve problems. So as a start, right, how I usually do this is you can always post any question in the chat whenever during my lecture. Therefore, don't wait until the end. Just post. As soon as I see the chat window moves, I know you have a question, then I can stop and explain further. The motivation is you definitely use services like Tokopedia and Shopee, right? So these are services that sometimes you feel, oh, wait a minute, they give me quite good suggestions. And that is a scenario you may be curious how they find out what I like or what is perhaps next thing I want to buy. Or maybe how Gojek or maybe Grab find out where to put most drivers, because that's the time where more people need the drivers to be nearby, right? So that you don't wait too long. And even an example in healthcare, how hospital knows which group of patients have higher risk, that they can also plan ahead, getting the right people, have enough medicine prepared for this group of patients, or even take preventive steps. That's very important to make sure high-risk people and large number of patients, that they can do something to reduce the number of patients. So how to discover this group of people? And even can cities find out where are traffic congestions and so on, like what Waze is doing today? And one of the answer, not the only one, clustering can help you to do that. So as a general term, if you want to give definition, sometimes in exam you need to answer this, but I feel it's also a technical definition that you can keep as a basis is firstly an unsupervised learning technique, and that attempt to group things together based on the similarity of their characteristics. Okay? At this point, if you're from the subject data mining, you should already have learned about supervised learning. Is that correct? Pak Rico, is that correct? They have done supervised. So the other side of supervised is definitely unsupervised. And some key characteristics, since it's called unsupervised, there won't be any defined label that you can use. So as if you are training the model without knowing what's the answer should be. You definitely need to know this thing called similarity, right? And we can explain a bit further what similarity means. And very important, clustering are quite commonly used to discover patterns that can be characterized or discovered through their similarity. And finally, you want things that are similar to be closer to each other, and that becomes a group. And things that are similar on the opposite side should go to other groups, or even seen as noise or anomaly. So this part is where you have a bit of recap, right? If you have done supervised learning, you know you need data that has labels. For example, you have a picture of fruits. You need to know which one is an apple, which one is durian, and which one is orange. You label them, and then you can now train to let the system know which one belongs to which. And it's a learning from example kind of approach. And therefore, the more information you can give, that means the labels that you can give in the data set, and the better, by right, the model can learn and help you to recognize these objects in later times. Therefore, this has been very popular technique, right? Classification and so on, even deep learning. Let's say things you might be familiar with, things like YOLO, image recognition. All this often is a classification problem, and it's pretty much used in many areas, right? Like spam detection. the one challenge they face with supervised learning is the cost or the trouble to label all the data. And that's where if you have data set that has no label or even very little labels, that means you kind of know a few examples, but for the rest, the system doesn't know which one is which. And you still want to do something about it. That's where unsupervised method can help you to do that work to discover them. For example, without knowing which fruit they are, can the system actually discover the patterns and tell apart which one is an apple, orange, or durian? And I think to do that is not too difficult, right? You can actually tell these three fruits are different. Is that correct? Can you put a smiley face if you think you can differentiate durian from apple and orange? Yes. I can see some smiley face from one of the screen there. Okay, quite a lot of students there. Other people, is there a reaction button that you can use? There must be, right? Record, no, reaction, no. There's no reaction. Okay, then you can't do much. All right, if not, it's okay. I thought there's a way you can put something. All right, I can see some message. I can see thumbs up. Good. How about this? When you say what makes them similar, you probably can say the color are similar for the same fruit, and different fruits have different colors, right? So you have red, let's say red apples, and you have orange for orange, understood? And durian, what color is durian? Should be green, right? And even color itself helps you to see there are three groups, and maybe based on this similarity, right? The same color would have grouped the different fruits together. So you may not be able to tell what the green fruit is, but you know green fruits belong to a certain group, right? And later if someone tell you everything green in this group is a durian, probably you start to learn, that must be a durian in the future. And coming to this, before I go into details, don't you think this is also almost like how a baby or a small toddler, young 3-year-old start to learn to name things, don't you think? If you actually point to every single car that your young brother or sister see at 3-year-old and say every car, you say that one is a kereta, right? And I know in Malaysia kereta is a car, but I think in Indonesia you call mobil, right? Most likely the child will keep saying the future car that look the same, they will call it kereta. While everyone else say, that's wrong because it's not a train, right? Because kereta in Indonesia, most likely you refer it to a train. But human actually learn a lot from pattern matching, and by associating the same pattern they discover to things, you name them. And that's probably quite close to what clustering is doing. Therefore, you are not so much into predicting it, just grouping them. And once you can group them successfully, you can actually still name them and later now predict based on similarity. Actually, you can do a little bit of classification, but we won't call it that way. And yet you can do prediction once the groups are discovered. That will be probably more for the advanced topic. So some applications that you can imagine how you can use clustering. I may want to say maybe to help businesses to segment, to group their customers. By observing data you observe from your customers' usage, their behavior, maybe you can look at who buys what kind of product, and you group them based on their expenditure into budget shopper and also premium shopper. The same thing, right? For telecom company, can look at usage patterns, what time they appear in what area, to also target and say if they appear in, let's say, which part that I know, maybe Pokok Indah, right? And push some advertisement about the mall when they are nearby that area because of what they might buy. To discover this kind of grouping of customers, clustering can be one technique to help you to see, right, whether those groups exist, and then you can do things specific to the groups. You can also look at what I said earlier, like looking at the location or GPS location of all the passenger and all the drivers and see whether you can group them and make sure you can move people to the right place whenever the need is found, right? Similarly, you can also look at the patient's profile and so on for hospitals and group them based on the risk and decide what kind of assistance and resources you can arrange based on the different risk level. And finally, for banks, they may want to look at the vast data that you wouldn't know which one means what, but by grouping them together and see what has happened to that group, majority of them, you may actually find out certain profile that may highlight something is unusual, and you may want to take action to those groups, right? Finally, even traffic and so on, right? You can use patterns such as at what time more people are stopping at a certain area longer than usual, and that may mean there's some traffic hotspots that may exist throughout the day, right? And all these are the different scenarios that grouping the data to help you to understand and get more insights can be useful, and that's where you can also apply clustering to do that. So some examples later you can look and ask yourself, do this list make sense, right? And the industries that I mentioned earlier, you can see they cut across, all will have this kind of needs within their different industries. So the next part I want to discuss here, since we talk about similarity, it's just not about things are being same, right? Because similarity can mean quite a lot of things. For faces, we probably look at how alike two person may look like, but for computers, most of the time they want to calculate something that say, are they similar? And the easiest way to look at it is, are they near to each other when you can plot them on a certain graph, right? And there are a few ways to measure the distance. Okay, one, you can actually do a straight line distance, right? I'll show you a picture later, then you can imagine how that look like. Or you can even do a, Manhattan way, walking in a grid. And I think the best way to look at that is through this picture there. You can actually look at this. If you can plot the two dots on a, let's say, Cartesian chart, right, in the grid, there will be a straight line, the black color line, that will be the Euclidean distance, and that is how far A is from B. And these two things, you can say they are near to each other, like if they are GPS location, the nearer this distance is means they are closer to each other. There are also other areas that X and Y may be something different, but when you plot them on the graph, again, they are distributed according to how similar they are on this chart based on the X and Y. We call them the features, and the closer they are usually means they belong to the same group. So most common techniques and the libraries you use would support these two methods for you to calculate, and you can't really say which one is the best. I think it's still back to the nature of the data, but one of these should be able to tell, one item, right, or one instance could be closer to the other one than the others, the rest in the data set. A final thing, you can also use something like a cosine similarity is another calculation, especially for things like text clustering, document content similarity. Things like cosine similarity can also help you to calculate. All in all, there will be one or two techniques that you can choose that can try to explain how two things that belong together are similar. Like just now I did say color, right? It's something you can't really express with the distance like this, but maybe the color can be represented by different digits. The same color will then group together in the same spot, right? And that's how you can actually use that. So maybe by using the RGB values and you plot them together, you find the same color definitely will group together more. All right, that principle is still the same. Yeah. So the next thing I would like to introduce to you will be mainly 4 types of clustering that you can definitely spend time, right, learning more about it. I will explain more of the first 3. The fourth one, probably you may want to look up yourself. 3 ways that are quite different from each other. One is to separate one from another, and that's why they are being called partitioning, right? And when you put them on the graph, you try to start splitting them into different groups, and through some clever calculation, you try to create those groups, right, into, let's say, circles. That's one way of calculating it, right? And divide them into how many groups that you would like to identify them as the groups that exist in your data. There are also another technique that try to form hierarchy, right? That will be the second one, hierarchical methods that try to look at similarity and connect them so that you know, for example, a bottom up, right? How two items are closer to each other and how they may belong to another group, like maybe different types of food, okay, that you may have in Indonesia. Maybe a simpler one, how many types of sambal you have and how you group them together, and they actually can form a hierarchy of different sambal, and that's how you can differentiate them at different levels to also see the distinctiveness between maybe different types of sambal you may serve in the restaurant, right? I'm very sorry, it's before lunch. I'm talking about food. I hope that doesn't disturb you too much. Thirdly, instead of just using distance, you can also actually use something that is based on how dense your data are being grouped together. So the distance is no longer about how far they are from each other, but how dense will be the data. Density may not be just distance, but can even be a number of frequencies. How often does it happen, right? And that forms some kind of idea of how dense is the data, and data that happens more frequently together and closer could form also a group, right? That would be density. And finally, there are other things like you have grid structures that you try to split them into groups, right? That we will leave it for you to explore later on your own. So before I move on to each technique, any questions so far? Right, I don't see any question on the chat. Thanks, Rico, for posting the link. Right, if no questions, I'll move on to the 4 techniques. This part can go a little bit technical. If you face any challenge or you need me to repeat, just type in the chat, and then I'll look at the questions and try to repeat or go back to the previous slide if you need me to do so. So first, I think the first one I myself learned earlier, right, about clustering is K-means, and I would say it's definitely one of the most popular, if not the most popular technique, and it's pretty simple and intuitive, and it works surprisingly quite well for many scenarios in terms of finding, right, existing groups that you have, especially if you have two sets of data, 2 features that even with your eyes, you already see them appearing together as a group. This technique most likely can help you to spot the groups quite successfully. And the approach is really by checking a certain point in your data and try to see how many points are closer to this point that you have selected, which is called centroid. And from there, you try to move this centroid closer to where the groups is, and that's how you move towards the center of the groups. I have a video for that, so that it might help you to visualize later. So this will be the algorithm. You can see first you have to still decide what is the number of cluster you want. Many people say this is a weakness, which can be true, but imagine you roughly know there are 3 types of fruits. Then you can say, then let's assume there are 3 groups, and you start randomly put these 3 locations among your data and say, now start calculating how many of the existing data point is closer to each of these centroids, and now try to move this centroid closer to whichever groups you think it belongs. Repeat this enough times so that the centroid stabilizes, and that would have been the group you are interested in. So you can see the whole process will not be too different from this. You have the K random points, and then you assign it, you update, and you repeat this. And let me see whether I can share that video and you can take a look at this. And I better hope I don't show the wrong thing. Let me go back to my video screen. Okay, let me go back. All right. Okay, this is still not the right one. Let me go back. Yeah, this one. All right, do you like to have some music? Then I have to make sure I share sound. But can you see is the video screen there? Because I shared the whole desktop, so by right you should see it. No, share sound. Okay, how about this?
Yeah, we can see it.
You can see it? And
Yeah.
if there's music, it would be good. If not, I'm sorry. All right, can you all see how the four squares really move to the center of each group? Right, put a thumbs up, then I know you got it and the video actually worked. So this is what I meant by at the very beginning, the 4 points can be quite random. Let me come here. You can see these two are too close. This should have been here, right? But it doesn't matter, okay? Because the calculation will start to assign what is closer to this point. So you can see the distance. Anything that is closer to this square, they call it yellow, which is half right? Because this is basically should have been blue, but it's still noticed as yellow, which is fine. Then you can see they slowly will try to move this point closer to where they think it should be. And when you recalculate the distance, now closer to this point are more, let's say, towards the actual group, right? So you can see more blues are now blue instead of yellow, and similarly here. And that's how you can see this point will always move closer to where the data is, all the way until the last point. And I think this is a very clever mechanism that it doesn't matter where you start the 4 points, as long as the distance is the factor, and actually very important, your data do show something like what you see here, right? Like before the clustering happened, even you can tell there are roughly 4 groups. Is that right? And then this technique, if you give the right K, it will work. Of course, the question will come, what if I say K equals to 5? What will happen? I will say likely, if you can see my mouse pointer, blue, pink, and yellow will be correct. Likely, orange may become 2 groups, right? You have the upper orange and then the lower orange and become 2 separate groups, because that likely can be 2 other groups also, looking at the structure of the data. And if you put something like only 2, K equals to 2, then there will be only 2 centroid. You likely may get something on the upper right and the lower left. So that is that challenge people will have and say, it's not that good because, right, there's this K that if I do not know much about my data, how would I know what K is, right, in order to find the right one? And there is an answer for it. But so far, are you okay? Do you see my slides again? Okay, I hope it's sharing the right thing. Let me see, I can check that, right? I can check, yes. So I think that is exactly what we will discuss next. It's actually quite straightforward and it works. You know, the groups can be discovered even within 5 iterations. You probably likely will see, yes, it can guess it quite well. But the challenge of not knowing K is probably one of the biggest challenge. And other than that, you may also want to look at a challenge like is actually a circle shape group will be very good, because if you're looking at distance, they are actually looking at distance of a whole distance that is same from the centroid, right? So they do expect the data to fit in something that looks like a spherical cluster, and that's why you see the last point. Okay, if your cluster is actually a little bit funny shape, then you know sometimes this technique may give you some challenge. Yeah, so most of the time, you know, our data may not be in funny shapes. It will work, and if the initial centroid, right, is also quite off, then it will take longer to move closer to where you want. And finally, you look at this sensitive to outlier. Let me put this screen back. What if some of this data, okay, like this field, they are not really pink or blue, but they are noise. The K-means technique will still actually try to assume it's one of the pink or blue, right? And outliers can really skew the result and misplace some of the let's say, instance into the wrong group, right? And these are a few things that you may also need to understand whether your data has this nature. For example, if you plot your data based on the two, let's say, features that you want to use to do K-means clustering, if you see them in odd shapes that cannot fit into a circle, and there are quite some that they are definitely outliers, they are not data that you should be seeing, and you can't clean them, then you must be very careful in using K-means. That K-means may also wrongly cluster some of the data, and you definitely want to test it. Okay, so this part, I think you can definitely try out, right, and see how it works for you. In my example code, you can see this is by using the iris data that you can very quickly, right, run it, and the command is K-means, right, and by running this, you should be able to already plot the chart that can tell you what this cluster is like. So I encourage you, right, after this class, the sample code is also there. It may not be 100% the same thing, but definitely you would have, right, an example that you can begin with. And I understood this class is using R, right, not Python, I hope. Is it correct? Is this a R class that you learn R to do all your data mining? Okay, if that's true, then the R code will be useful. If not, I hope your lecturers agree. You can put this code into ChatGPT and say, can you give me the Python code? And then you can have the Python example. Yeah, it's not too difficult nowadays. All right, so the biggest challenge that people will say, it's a very nice technique, but I couldn't do because I don't know what is K, right? When I look at the data, that could be 3 fruits, it could be 5 fruits, or even only 2 types of fruits, right? How would I know? Actually, there are a few techniques. I'm going to show you at least 2, elbow and silhouette, right? So that you can see how some of this technique can actually detect and tell you which one is the right one. So there's this technique that you can calculate, right? The sum of squares, which is this formula within your cluster. And you can repeat this for different value of Ks. That means you assume I do not know how many groups. I'm going to do it with 1, 2, 3, all the way maybe to 10. So you have a range that you think, you want to try out. You're going to get this WCSS value and plot it against the number of cluster. And you will notice for many data set, there's always a point that this thing called elbow will happen. And usually at the point of the elbow is also where you say that could be my ideal K. All right. So to understand this better, those who have PowerPoint, my PDF, you probably already see this page. This is one example that if you run, let's say, the iris data, I hope this is iris data, and you will see some of this value being plotted here. As you increase your K, do you see around 3, 4 is where it will try to converge that the range is almost similar. Of course, it's not exactly the same, but it did slow down the changes. And normally we say at the very point that the value starts slow down, right, in terms of its differences, that could have been the ideal K. And I would assume by plotting this, I would suggest there should be 3 clusters in my data. Therefore, I decide K equals to 3 will be the best K value. Right? And today, with all the computational ability that we have, to repeat this calculation for different number of K is not too challenging. And often we don't really expect in our data to see 10, 20, or 200 groups appearing there. So if you're saying it could be 5 groups, 4 groups, this technique would be actually more than enough for you to test and find out where the elbow is. And that's where you have this optimal K value. Yeah, so far so good. Any question on this? All right, so I take it as all okay. So therefore, the problem of finding K is no longer there. And finally, lots of time we not only check the value of K through elbow or silhouette, we also visually look at the plots that we have, right? Like just now, the pictures you can see visually, you roughly also say there's 4 groups. And I'm quite sure running the elbow method, you will get number 4 as the turning point. And of course, the clustering will also work. I think these few ways, you should be able to be very sure I can find K equals to 3 quite fast. Do bear in mind, this example I take here and the example I just showed you on the video is 2 different data sets, so they are not the same. Okay, so to run this thing, you just need to know, right, you have a loop that can actually build the k-means differently, and you would like to repeat this 10 times, right? That's where you have this loop, and this way is a shortcut that will actually repeat this for the 10, this is a 10 times, and now you plot it and try to show each round how the WCSS will look like based on the number of K, and you should get this graph that I've just shown on the left-hand side. All right, next is the next technique, quite different, that you also calculate this silhouette coefficient as I here, and I is then, of course, the different points, right, that you want to measure. And you can see, based on this, you can get a certain score that you can use it to compare with the different number of K. So once you have done this calculation of the silhouette score, you will plot them and see how you can see the with how many cluster you would get a average, right, silhouette score that is higher, and that will likely be also the number of cluster you want. I think this is one way of showing it, that you can see based on the example code. I think I have it here, right? You can also test it out, and you should get this graph, and you may want to look at then say that is the highest score here, that maybe K equals to 2 would have been the better result. And in this case, 0.5 I thought is a bit lower, but even anything higher than 0.5 can be considered sometimes. So you might also have a option of saying maybe 2 or 3, right, could work. And I think that's where you roughly have some choices that you can validate and check. Okay, so that's another example that you can try it out. The code is here, and you can see you still have the loop, right, to try out the different case. But here you try to get the SIL, right, the mean of the values that you get from the silhouette function, and that's where you collect the score. And with that, you can plot, and also to find out which one has the highest value and help you to decide the number of the right K value that you can use. Okay, so this is another technique. I think you can draw the silhouette. I think there's a plot that can show the thickness. I didn't have the picture, but you might want to look up in textbook or also even YouTube. There are examples that they show you how you can plot this. All right. So with this, let me quickly move to the next technique. That is the hierarchical tree structure clustering. Okay, you start both ways. I mean, not both ways. There are 2 ways of doing this. You can always start from the bottom, means the smallest groups that you can discover, and you try to look at which of these groups are more similar to each other, that you merge them into a bigger group, right? So that's almost like the example I tried to share with you. You have tested all kinds of sambal, in different cities, and you try to now use certain features to say how the taste, maybe the color, right, that they may be similar. And you slowly build your own, structure of how you can understand how the different groups of sambal can be, drawn into a tree structure. A few things we can do with this simpler one, like maybe types of animals, like you want to look at animals that are more similar, maybe, the cats, the dogs, the birds, and so on. And maybe to see how similar you can look at, maybe today, bear children, do they have, feathers, hair, 4 legs on the ground, 2 legs on the ground, can they fly? And that's how you them together and start grouping a common category out of the similar clusters, and slowly different level of clusters can be grouped together all the way to the top part, which you say these are all the animals, right? These are another example. The opposite way is top down, which you don't start from the smaller groups, you actually start from the top part. So it's the opposite of the hierarchy that you are building. You can start with, let's say, sauces, right? And then you have the sambal and everything, and then start breaking down into the different levels that differentiate them, all the way until one level they say, I wouldn't want to split it further because that's the deepest I would like to go down. And you still have this tree structure, but the difference is, one, you start from the highest level, right? The biggest category that encompasses everything, or you start from the smallest group and start grouping them up to the highest part. That is these two techniques, agglomerative and also the divisive. So you can roughly say the first one is to start combining them, and the other one is you start dividing them, and that's the top-down technique. And the decision whether to split or to combine, based on either technique number 1 or 2 here, you still need something called the similarity matrix. You can look at, a minimum distance between them. You can also look at the maximum distance between them. You can look at the average, and you can even, look at the variance, right, between the clusters. And these are the different techniques how you decide to split or to combine them to finally form this hierarchy. Yeah, I have also some examples here that if you run them, you should be able to see the tree structures, right, being formed there. Let me see if I can run one of them since I don't have a picture here. Let me go to the example. If you have R on, and also, you have loaded the R file that I've uploaded into the Google Drive, you might want to go to part 4, right? And that's where I have this example of iris. Right, let me copy and paste. Oops, I think I've plotted too much, but let me put it here. Can you see my picture? I know it's not the biggest, right? And I've definitely plotted too much. So let me go back because I want to show you the other plots. So you can see this example based on the iris. Okay, you can see every data point, if you take them as the smallest, okay, and you try to put them arranged in the way that the most similar points, they actually being grouped together. And now that's how the smaller groups start merging together to be bigger groups. And that's how they all slowly come up to the highest level, right? Which at the end, you think there's only one group and now the two, and that's how they split. Okay, and based on this, you can decide at which height you want to stop, and that's where you can also say there are basically 3 groups that I want to detect here, right? If you remember iris, there are 3 types of iris, how could the flower, right? I think it's a flower petal. So these should be the 3 groups you will discover based on the level of depth that you want to detect. So you roughly kind of draw a line across here with these 3, means there are 3 groups below them. And that's how you separate them. So this is one of the example. You can see the other one. And I hope as I speak, you do get to see the picture I'm showing through my R Studio, right? You can give me some signal if that's right or wrong, right? So as usual, we put a thumbs up or so on. I should be able to see it and know, yeah, I'm looking at what you're looking also. Okay, so this is those examples. You can definitely just run it, right? And look at the differences. And later, I even have the example that if you do the clustering, you can actually also now plot them back, right? And try to show how the different groups may look like on this separate chart. And depending on which, feature you choose, right? This may appear differently, but this will be the outcome how the cluster has been detected. Okay, so try out this code later, right? They are together in the demo code, and you can definitely play around with this to test it out. So a little bit on the advantage and disadvantage of the hierarchical clustering. You can see this technique now, you don't have to define K directly to run it, because they will actually, try to group together based on the similarity all the way to one big group. Is at least something deterministic, means no matter how you run, the result will be the same, since things don't change. The others may have a slightly different starting point, like k-means may start differently, and you may end up having a few instances in your group that can be different every round you run, right? So that, maybe something, a feature or a characteristics you may want to consider using which technique, right? The distance metric can be a bit more flexible, and most of the time we do use this, to categorize data, to build taxonomies and so on, right? I think that's one of the main usage. They also fit into these three structures, if you want to form that. And of course, the computational effort will be a lot higher here, right? If you have studied Big O, you will understand this compared to the previous one. Here the computation complexity, right, is definitely higher, and large data sets due to the expensive computational needs, not so cheap or suitable, right? And you can't just undo this merging and all these things. Whatever that's merged, they are all fixed there. Noise and outlier could be something, right, that the system can be, let's say, affected. Yeah. And of course, the choice of linkage, the distance that you want to perform, the merging and so on, they, of course, will give you different outcome, right, depending on the nature. That's why in everything you do, in our experience, and we usually tell students about this, is don't just use the technique because it's good. You definitely need to understand, right, the data sufficiently to also have a feeling what kind of data may best use which type of technique, right, so that you won't choose certain things that may be less appropriate and end up, right, it may not do what you want to do. Okay, so the third type, which I like a lot, is no longer using the similarity and also the, let's say, hierarchical approach, but based on the density, right, of your data. Especially if your data is noisy, right, and the shape is not so much like a circle, then a density-based technique could be quite useful. And the concept is, if you roughly have an idea how a certain cluster should have a minimum number of members, or they call it neighbors here. That means you kind of decide each cluster must start with how many points within the group, and now you start comparing and say, within a certain radius that you have decided, how many more points can you count, right, into this group? And the more dense it is, the stronger this group should be formed, and that's how you run through an algorithm in order to discover the groups. And the advantage of using this, especially if your data also look quite good, in terms of visualizing it, they are obvious. You no longer need to tell whether there are number of K clusters that you start guessing. You can just define the minimum neighbors, right, and start checking the radius that you are looking for, and it will now try to fit as many as possible within the same region. And even things that are not within this group, they will be regarded as outliers, and that's where noise will not be included in your group. And you can even use it to then tell which one are outliers, that you can do certain things like anomaly detection and so on that's possible. And therefore, noise wouldn't disturb or affect the formation of your groups. So I have an example here. You use this, and from code-wise, you don't really see anything because you just change the command and run it and plot it. You will still see the picture itself, right? Let me see my code here, dbscan. You can also look at it yourself. It's part number 5. Okay, let me show you a plot, and you can see how that data could work. Okay, that's the dbscan. Oh, I think I didn't put the right values. So you can see they still actually group everything together. Yep. So you may want to play around with some of the values here so that you can actually decide the neighbors, right? I think I didn't tweak that well. So you might want to tweak some of the numbers so that the minimum points and also the radius can be adjusted. Then you see how the groups will appear on the example code I put. Apology for that. Yeah. So in this case, I would like to give you an example that I kind of feel this makes sense, right? if you have enough, let's say, report of location where, let's say, traffic happens, that means whoever is on the road can actually highlight and say, oh, I'm in the traffic, like what Waze is doing. And based on that, you will now have the reports, in your data set. And you can say, as long as this longitude and latitude are close to each other, and if there are maybe minimum 100 points, right, that exist, that should be a cluster that I would like to, count as a single cluster. So you can imagine if you plot, let's say, the whole Jakarta, and if the groups of latitude and longitude that appear in the same region exceeded a certain frequency, right, a certain density, we can say maybe at that particular time there is a traffic. So maybe over 100 cars in the same region, right, would have been a traffic situation. Now you can say whichever zone that has lesser, they are probably noise, there are no groups there. And that's how you can now spot certain hotspot within a region as a possible traffic hotspot. And if this group exists within this time, or you can even run a simulation to say, what if the numbers increase in, minutes to come or hours to come? You can now plan and say where I should send my traffic police, where should I change the signal, of the traffic light timing so that we can clear the, let's say, the traffic situation that we have. So, of course, prerequisite, each of these cars should send you all these GPS coordinate, right, in real time. So, talking about this, do you know now with this possibility, who will be the best person that can actually tell there's a certain traffic happening in which part of the city? Who will that be? You can type in the chat who you think. In today's daily life, right? Who will be the people that collects GPS coordinates every time, every moment, wherever you go? Do you know that? Anyone want to type your answer in the chat? Are you all still there? Just to make sure you are still following the class. I'll wait a bit until I see an answer. Anyone? No answer will be right or wrong, okay? Let's just make it a discussion. Don't worry if you may put the answer wrongly, right? I think most of you would have gotten the answer. Anyone? Can just type in the chat, okay? If you didn't notice, I'm not sure how often, especially the Android phone users, do you notice Google do send you reports of where you have been in the past 3 months, 6 months? And Google actually keep tracks of our locations wherever we are, right? And imagine if you have a phone, you're running Waze or Google Maps, when you are moving with your car or your bike, wherever you go, when you stop, the updates that you send to the server while you are checking your location and the map, right? Those service provider also get your GPS location in real time. And of course, at any time, if I can now see how many locations, and I can now form this, let's say, DB scan groups, I would spot the hotspot quite easily, and I can now see whether this hotspot changed the location as time goes. If not, that would be a signal that these are, the different places where there are enough cars in the same place at the same time, and now I can do something about it. Yeah, thanks a lot for the comment. Exactly. Google Maps has many functions, but being able to see traffic likely has to do with your real-time updates of your location when you are driving. And imagine all the drivers around you are also sending those information to the server, and we will want to see at what time many of these updates are closer to each other for a longer time in the same spot. That's usually, I think the Indonesian word is called macet, right? Yeah, that's how the traffic is detected. Basically based on just the GPS coordinates. If you're always moving, the number of cars in the same place at the same time would be a lot lower, normally. So you can actually do some of this. I think the code that I did put in one of these example is a simulation, right, of this, and you can actually generate some random values to see whether this, data do appear together or not. And I think you can see the hotspot yourself also. So I hope this example can give some idea, right? Just curious, how many of you roughly get the idea of GPS appearing can actually, highlight the hotspot? You can maybe put a thumbs up in the window. Oops, sorry, not this window. Let me check. Oh, okay, wrong window. Now you see everyone. Okay, I can see all the thumbs up already. Now I think I got it. Yep. Okay, you still see my screen, right? Let me see. Okay, good, got it. All right, I think some of you get it. The rest, discuss with your friend after the class so that you can share, try out the code. Maybe that's how you can then understand this concept also. So the next thing, I think, let's come to some evaluation technique, right? Some of this, even I find it new when I prepare this. So definitely worthwhile to try it. And there's some sample codes you can check. But the whole thing is, if you have no ground truth, which is probably not true if you're doing an exercise. Most of the time, exercise, you do have data that has ground truth, so you can check. But if you have your own fresh data, if you don't label them, you wouldn't find out whether this clustering is good. Therefore, earlier, if you already have done the elbow method, you already know this WCSS technique, it is one of the way you can actually tell, how well it performed. That's how you use the elbow to detect, and you can also similarly use it to evaluate. And there are also other techniques like the silhouette score, right? And I think I also include the example of the Davis-Bodin index, and the rest you can also look up in the internet, right? If you have ground truth, they are even easier because you compare with the ground truth and say, how well did your clustering technique perform? And therefore, compared to a ground truth, you can then say it is well. And finally, you can also perform this clustering and you check with domain expert. That means like you spot all these things, you go to the, traffic police and say, do you agree that the hotspot I detected is also places that have more traffic than usual? And they are the one looking at all this situation every day. They should be able to spot it and say, yes, your model is correct or wrong. So that's also quite useful, right? To go to the domain expert and get their check or validation to confirm. So you can see, by using the WCSS, which is what we have done, the lower the value means the better, right? But the lower also, you can't just keep going lower. You look at where is the place, right, where the elbow happens. I think we talked about that. That is probably also a sign that you have hit the right cluster, and that's the correct answers you're expecting. And similarly with the silhouette score, you hope, right, by the calculation, you can get a higher score, right? That also help you to detect the cohesion and also the separation or how the cluster form, right? And the next one, the formula is there. I think I have a code how you can do that. There's a library to do this, right? You can also check if there's a lower index of the DB index, then that will be a way to tell, right, the cluster is probably performing better than the other value of K and so on. All right, so some of this, as I said, the code is there. Like it or not, sometimes when you look at this kind of example, it doesn't tell much because everything is already in the library, right? Just putting G1 or putting DB, you get the value and you can already judge. For those who are interested to learn, I strongly encourage, it's not a must, take some time, maybe try to learn to even code all these indices yourself, right? Like do the calculation yourself so that by implementing it correctly, you should already understand what all this thing means. Sometimes one of the way to learn what the different calculation means is by implementing the calculation yourself. That means you don't use index.g1. You actually code your own algorithm that can perform, let's say, the Davis-Bodin index. By the time you get it right and your answer is the same as, let's say, the library from ClusterSim, that's also the time I think you can tell everyone, I think I understand it well since I can code it from scratch also. right? A recommendation for those who are interested to try out, do try that, to practice, to polish up, but also to understand better. Yeah. So a few examples I would like to go through. I'm probably in 2/3 now. I have another maybe 20, 30 minutes. I would like to just give you some examples, like maybe in e-commerce platform. You definitely want to know in the different marketing campaigns, you have data like how much they spend every month, how frequently they buy, what kind of order, values that they do, and even the gap between every purchase they make on your platform. You may probably say logically, people who buy frequently but spend very little, they may fit a certain customer profile. We call them budget shopper. And people who buy quite frequently and they also spend moderately, right? Then they are the regular customer. And you have maybe people who buy a lot every time, but they may not buy frequently. And that could be your premium VIP. And that might make sense. I was looking at some economy report and say when economy is bad, people no longer buy big volume because psychologically speaking, you feel you're giving out a lot of money at one go, right? You then started buying smaller amount, but you buy more frequently because these are things you need every day. The funny thing is you may want to check if you're interested about what I just say, right? The money you spend at the end, the total for the budget shopper sometimes may end up you spend a higher total than those who buy in bulk and buy more per order. That's a very interesting suggestion. So you might want to look up and compare that, especially if those students who are interested in data do find some of these, chase records and all this and see whether this statement is true. But I think buying bulk has one advantage. Usually you get a cheaper price when you buy more. And that's how some of the people save money by just buying in bulk, right? Yeah, but when economy is bad, buying bulk is too expensive, they may end up buying more frequently but spending less every time. So with this, I think you can look at the example course where we actually try to create the 3 types of customer by simulating some of the data. You can see here there's a the lower mean. This is what a budget expenditure average will look like. This will be a regular expenditure, and of course 4,000 will be higher. Right, so assume this is 500,000. I'm not sure whether the value makes sense, but you can actually put any values and randomize and create, let's say, that many sample data into the different segment. You can now put them together, and later you run this K-means. I'll talk a little bit about scaling later, but once you run the K-means and you assume there are 3 groups, you can now verify, right, whether if your sample would detect them correctly. I actually have the code here that you can also try to run and plot the data. Let me do this. Okay, so let me move it back. Now, moment of truth. Okay, this will be my data. And if this is the randomized data, we can actually rerun this if you want to, right? So you can say this is how, the visualization may look like. And if you're interested to know, right, how the segment may look like, okay, this is the second one, then maybe you want to run the next code. Okay, so if you look at the left-hand side, can you say roughly there are the 3 groups, one on top, one in the middle, and this one will be the final group, right? So let's look at the next code that you can actually now do this. Let me just run through the whole thing. I think, okay, we just look at the final results, right? And this is what the clustering tried to do, okay? Can they actually now, through K-means, spot the centroid? You can see one here, and one here. I know the color doesn't help, but this is what clustering tried to say. This looks like one group that may have this spending habit. So you can see this monthly spending and also the purchase frequency, and there's some correlation between the groups. Okay, we can also say maybe these 2 groups is a bit mixed, but not too bad. We can still see at least green is quite together with some maybe, outlier here. And similarly, the red color ones also get almost right. So you need to tune a little bit. But you can see now this is also the weakness. If these are three perfect circles, you would have detected it well. But since the final group is not a circle but something that is long, right? And that's why, the detection is not as well as we thought. Similarly, you can see this is by the purchase pattern, right? You can see the average order value. You do see this together, right? And we just need to actually compare that with the ground truth to see whether are they plotting it correctly. But you can see the three groups also kind of being guessed, right, to be at these three different spots. So I think this is an example of how cluster can be formed, right, in order to tell, let's say, based on the customer behavior, right? But now, when you know which group actually exists, you can also do some targeted sales to these different three groups based on their purchase habit. And the whole goal is, if you can engage them correctly and, not mixing them up, likely you may give them offers that they will end up buying more, right? Hopefully buying for what they need. But that's also how you increase your sale and also get happier customer, right? So segmentation helps you to identify them. And from there, then you can also now have better things, to serve them. So this is some example. If you can cluster these groups correctly, right, based on their attributes of their chasing habit, you can maybe give them, volume for the budget people so that they buy more, right, for what they want. You can actually offer free shipping so that they still will buy, since they're buying frequently, right? You actually still can get more sales. As opposed to maybe things like the premium case, you can see they spend a lot, right? So even they don't come as often, but you can give them exclusive access that they may appreciate, right? And therefore, all in all, you still get happier customer that will buy more. Yeah, so all these things you can see, without identifying the different segments, there's no way you can send targeted strategies to the different groups. You may argue and say some groups may still not be accurate, because what if some budget people end up in the regular group? Give and take can happen. But as long as you have majority that fits into a certain profile, some of this strategy will go to the right people. Because if you offer the VIP service to budget, they will not be able to use those features at all, right? And you definitely don't want to waste time in giving the wrong strategy or campaign, to the wrong crowd. So the final part, right? You can see we have another half an hour, is where there are some, steps you may want to look into. So data preparation is very important. So this part, we want to look at some suggestion like, can you handle missing values? Because if they exist, your cluster may actually look different if these missing values are not, let's say you didn't do anything. So you can impute, you can remove them, right? You may want to talk to domain people in order to make the right, let's say, action in manipulating this data, right, for the good reason, so that when this data is not affecting your modeling, you end up getting better, higher quality models that can help you to make certain decisions like what we showed earlier. Secondly, outliers definitely can really affect this, how we call that, clustering effect, because it's basically acting on all the data are valid and belong to certain groups no matter which technique you use. But outliers are there to confuse, right? To affect the system that the calculation may not go so right because of the outliers' existence. So you may actually want to use things like DB-scan in order to ignore and even detect the outlier for people to do something about the outliers, right? So that's where, some of this technique can be suitable. I promised earlier that I'll talk about scaling, right? Which is quite important that you also change some of your features to a standardized or normalized scale, because that has a lot to do with how you calculate the similarity. Imagine you have something that increases at the interval of 1, and the other axis, right, has a range up to hundreds. That a slight change here, right, may mean a lot in terms of calculating the distances, and therefore, if you change all this into 0 to 1, they are now compared and calculated in a more comparable way, right? And then the changes, right, between the different values or the differences can be also compared and detected more or fairly or more comparable. I'll put it that way. Okay, so do consider when you look at your data whether you can actually carry out scaling, which is not difficult with libraries, and that scaling may help you to come up with closer, better clusters, right? So anything that's distance based, the scale that you are using can also affect the outcome of your cluster. And of course, when you do clustering without ground truth, you are definitely need to be careful about what kind of features you are using to compute, to compare. Anything that's irrelevant or don't create those differences or highlight the similarity may actually end up confusing the system. And these are features you want to remove. Or secondly, you may want to use something like a I lost that principle. Component analysis, right? In order to reduce your dimensionality, that you also end up with features that matters, and now you use it to do clustering, may help you to discover them easily or more easier. Yep, so I think I have some of this example that you can see how some of the scaling can be done, and usually there are also libraries ready that you can do, like a z-score scale. You can put a normalized function that can then also calculate and help to perform these two tasks. Okay, so do look at this code example later and try out and also play with it yourself. So a few things you definitely want to do when you're practicing clustering. Definitely explore, understand your data, and as I said earlier, visualize, plot them, especially across the different features to see which two features, right, make sense for you to perform the clustering, and also look at the correlations between them because they mean something. That helps you to then decide how you want to do the scaling, clusterings, and so on. Yeah, and the better you understand about the feature scales and distribution, you can also then convert or scale your data accordingly in order to perform successful clustering. And when you are now doing the clustering, do test with different, k values or different parameters that you can examine the output, and also use that, right, multiple times, to test it out. Because by only comparing, you can notice the patterns, the trends, and from there, you can also make better decisions to say, it makes sense to use clustering to discover them before you then decide with the different segments identified how you're going to use it in order to, let's say, benefit the people who need to maybe spot these things, and get those insights. And finally, if you have that access, do get domain knowledge so that whatever you decide in your modeling process fits and don't disagree with what an expert or domain expert may tell you, right? So they can help you to remove many of these doubts or uncertainties, and then in return, you know how to tune and set the parameters correctly to get the best cluster outcome that you should be getting. And after clustering, definitely look into the clusters you have built, see whether you can interpret, explain, and present the insights that this cluster may give. Use different metrics to validate and to evaluate so that you know this cluster stand. And also, if you have results, ask yourself, do they help in any way, right, for especially businesses to make use of this information? As I said a few times already, talk to domain expert, get their feedback, validate and verify. And finally, something I hope you have learned how to do this is to document everything. That's why the code, right, that you write with the right comments, report that you write are very useful, very important, because they allow you to document the methodology that the third person can actually look at it, examine, and also help you to maintain, to reproduce the results you want. I think documentation is really, really important, and do get used to doing it, and you thank yourself, for making sure everything is well documented. Yeah, a few things here, what you need to avoid. I think the scaling feature is something you definitely want to pay attention to see the effect of scaling and without. And that helps you to make sure, right, the distance do not skew your data and make it biased. Make sure the shapes is kind of, anticipated so that you can say, can I actually use k-means for this, or maybe use dbScan or hierarchical for another type of data, so that you can choose the most suitable one, right, for the right purpose. Don't ignore, right, outliers. Okay, I think outliers, if you didn't pay attention, if you use k-means, they actually end up distorting your outcome and give you the wrong grouping. Okay, use things like elbow technique, silhouette in order to find the right K, then you will get the groups more accurately. And don't try to explain more than what you want to do, because here you can see, over interpreting, they may not be meaningful or as useful as you thought. And of course, use different metrics in order to verify that you can also say not only one, but maybe 3 different techniques confirm the outcome is okay, and therefore, the report is good to go. So out of this whole lecture, I think I'm coming to the last 7-8 slides. There's a summary here that you can also use it to check whether I put something right here, and also would this be something can give you an overview, and this can be also a checklist, right, that you can check, if I have certain requirement, which technique would fit into my requirement well, and therefore I want to use it for my own work, right? Maybe this table can be used for you to make those decisions. Yeah, for those who are interested, definitely these are topics you might want to look into, how to reduce dimensionality. Having 20 features is not something you can cluster so easily, and let alone to plot them so that you can see those clusters well. Therefore, PCA and so on, all these are good techniques for you to actually reduce the dimension, and then it's easier for you to also visualize, to see the clusters and decide, right, to interpret them. You can also use ensemble technique, like multiple clustering, recluster, and combine those results to form the most accurate clusters that you want. There's also a semi-supervised way that use some label data. I do some of this in my research, that we label a small sample, and with that we then go and cluster, right? That could be another technique you want to apply. There are also other things like time series and deep learning. These are more advanced additional topic that if you are moving towards a certain project that may need them, those are definitely topics you might want to look at also. All right, so what makes clustering difficult? I think these are a few things for you to think about. Because of dimensionality is always a challenge, right? I talked about it already. And data that has categorical and numbers, numerical, is also something it couldn't solve immediately. There are other techniques that you can try, like, using goal distance. You can actually translate, I forgot that's the technical term, but you can translate them into all numericals in order to, compare them. There are quite some techniques that you can apply, right? And the scalability, how you can deal with very large number of data points while the techniques are not as scalable. There are also things that you can actually do, like sampling or even using a mini batch, k-means, right? Can help you to do that. And finally, something I always think important is it's always nice to do data mining and all this, but if you have a model that works, give you certain values, but yet you don't know what really happened, how can you explain the clusters to your stakeholders, and how you can tell them this really is important information they should pay attention to? I think the ability to interpret, to explain and communicate your data with the domain expert is very, very important. and therefore learn how to visualize them, how to profile your data, how to get input from domain experts or even present to domain experts so that they can tell you what you show or what you've done will be correct or useful. Okay, so as a kind of summary, I hope you have learned today about a unsupervised learning technique that maybe the examples I've shown you earlier and you will try later can help you to see how even without labels, without the supervised information, you can actually find hidden patterns that in return still help you to distinguish things and also to actually spot those patterns in your data. We have talked about a few techniques, but K-means should be something you should definitely learn first and get familiar with it. And you learn how to choose the right K value in order to spot the groups correctly, learn how to prepare your data, how to scale the features correctly, and also then how you're going to handle outliers. Finally, learn how to do evaluation to validate in order to find out whether your clustering works. And next, you may want to also explore the other techniques either we have shared here or even some other that you can actually look into in the future. Yep. I think this part, we can leave it to Q&A if you are interested, right? Else, I will leave it for you to explore yourself and see whether you can find sample data or even simulated data that you can apply clustering and see whether you can now run some of this to say, well, it can help me to detect some of these patterns and it could be useful, right, for your future clients or, company. Yep, so some of the books, I did some fact check. I think they are quite okay. This could be some extra reading you want to do. The libraries, I think you can see they are being posted in the code. And also, there are data sets that you can already begin today. Kaggle, UCI Machine Learning Repository, or even Indonesia has an open data portal. Start working with all these things so that you can then, practice and get familiar with this technique. Yep, and a few suggestions for you, right? Get familiar with the R dataset. You can start directly without worrying about converting, importing them, right? You can join competition, take real dataset. It gives a bit more motivation to find out things that are interesting around your neighborhood, around your city, right? And finally, when you are more fit and ready, you can even collect your own data, right? Look at topics you are passionate about, and you can now apply clustering to solve those problems yourself. Yeah, so some questions that may help you to, check later when you revise. I've listed them here, so I leave this as a kind of example, right, for you to consider. All right, I think that's all for today's session. I left some time. If there's a question and answer, I'm happy to discuss with you. And I hope in the past 1 hour plus, there has been something that you can learn from this lecture, and happy to get your feedback. Yeah, thank you very much.
Thank you, Prof. So, is there any some questions that you want to ask to the Prof. Noon about the materials or the presentation, guys?
You can type in the chat also if you wouldn't want to ask. I can try to understand and even reply in Bahasa Indonesia. So if that is one of the reasons you're not asking, but I think we can also try to practice English too. Yeah.
Okay, Prof. We will wait for your questions. So I would like to ask some questions that interested from your presentation.
Yeah.
So before that, you said about the hierarchical clustering. In the hierarchical clustering example that you mentioned, we can choose the different linkage criteria like a minimum, maximum, and average distance itself, right?
Yep.
So how do we decide which linkage method is most appropriate for our specific data set like this. When I need to use the maximum, when I need to use the minimum or average. So
I think the question is the same for every other technique in clustering. Since you don't have ground truth, you can't just say which one is better. I think you still need to have some knowledge, and that's where you work with a domain expert in order to understand what is the nature of the data that maybe the minimum distance can help you to discover the similarity better. And that's how you use it to link them up, right? And that's how you group them together to form the hierarchy, bottom up, or maximum. I think it has to do with the nature of the data if I were to generalize the answer. Because at the end, it's not because which one gives you more beautiful outcome means is correct. It has to do more with the type of data that you realize by using this, they form better linkage, right? You want to put that way, that the groupings that they make more sense. See, if you use the wrong type, I can't just directly give which one because I didn't run those code with the data. For example, types of animal, maybe one way is better to group them more meaningfully than using the other technique. You realize the grouping may not be logical to us, and they may form even wrong groups, as they calculate. Then that's the time by showing this to the domain expert. Usually they can tell you, but this steps the system went through actually doesn't make sense. That's why one of these cluster is no less appropriate. Then the other technique. That's why you run a few, you can show them and they will give you feedback. That's how you say it. From this feedback and you validate them, you can tell which, let's say, linkage can serve better. Yeah, for hierarchical, especially, you want to look into this factor. For k-means and all this, is more like trying the elbow that you have maybe a k value that is close to each other, like 3 and 4, that you also form the different cluster and show domain expert and say, does this group actually explain what you have observed yourself? And if they are meaningful and represent what you definitely know, then this would have been the better, like, for example, none of us know what fruit it is. So based on the metrics, we actually form 3 groups of fruits. So we go to a, fruit expert, and the person will look and say, yeah, all the apples are in the right group, or the oranges are in the same group, and all the durians are not mixed up. Your grouping looks correct. Imagine you have chosen 4 groups instead of 3. Maybe there are 2 groups of durian due to some whatever, or maybe apple. Apple, you have green and red, right? So you form 4 groups. The expert may say, these 2 should be the same group, so reduce them, right, into this. It may mean then you have to choose a different feature, because if you use color, it will group into 4 successfully. 3 will be a bit confusing. But if you look at maybe the shapes, assuming apple is not exactly the same shape as orange, then now the 3 groups will make more sense, right? Even 4 groups, they are quite close to each other. I hope something like that you can imagine, and then that kind of makes sense how the thinking process should be if you are doing clustering. Does that answer your question?
Yeah, thank you, Prof. So
earlier I've done a project. We use a Wi-Fi signal and we use a density-based clustering to form location spots that we can use it to detect which room you have been in, and we try to use that to also form the different locations you have spent time in. And the approach, I think this paper is now almost 15 years old. That was done in 2010 or 2011. The idea is simple, and I hope you all can imagine that. If I stay in this room, wherever you are now, your phone will be picking up almost similar radio signal from the access point. And the further access point will get weaker signal, the nearer access point will be stronger, and they will be within similar range. And that's how I form density of the, access point signals. And if I move to another location, this pattern will change. So for myself, over time, the places I've stayed would form different hotspot of the locations, and we use that to build location fingerprints. And DBScan actually help us to detect that. And the concept of frequency is, if I'm in the same spot, the frequency of the same range of the radio frequency will keep repeating. So I get higher density of the radio signal in the same location. And that's how we form meaningful clusters, throughout different collected data. And we use that to do localization using mobile phone. So that's another slightly more complex use case, but yet clustering helps us to detect all these things quite naturally without having the knowledge and even the need to label, right, the location in order to detect the location we have been visiting. Yeah, so imagine you turn this into GPS, they will also in the same way allow you to detect the locations you have visited frequently, right? And DBScan could also help you to do that. Yeah, and for interested students, it's not difficult. Write a logger yourself, collect GPS as you travel the whole day, and use this different technique to see whether you can spot groups that group your locations that you have stayed behind, right? And see whether it surprises you that you actually can see different stops you have made throughout the day just by using some of this technique. Maybe Mr. Rico write that as assignment next, yeah.
Okay, sure. Okay, Prof. Maybe
Chat
this is
or something like that. Let me see. There's a Q&A. Okay. Okay. Unstructured data is a bit tricky because it could be, let's say, images, right? It could be text, and each of them may require a slightly different technique, right? So I never believe in most appropriate technique for such a big, category of data. But if you have something so specific, like I have voice, I have speeches, which technique? There could be some answers. And the easier way is not for me to tell because I wouldn't know everything. You can look at different scientific paper that actually attempt to do all these things, signal processing, speech recognition, social media text understanding. You find some are using clustering techniques, right, in order to find hidden patterns among the groups. And then you have your answers. So I can't just give an answer since the question is very broad. Because unstructured data is like everything, right? 50% of the data that you deal with is 50% structured and 50% unstructured. Not from volume, but from types of data, yeah. I made up the 50% anyway. Yeah, I think images, right? If you talk about videos, I have one research group, my students and I, we are working on using UNet, right? Image segmentation to do unsupervised way to detect granular objects. I'll put it that way. Like, let's say you have like let's say medical images. You have a lot of cells. You want to detect them. And different types of cells, you can use segmentation to detect it. We use it on engineering diagram on fuel jet droplets and stuff. And we use unsupervised technique. Actually, our approach is more like semi-supervised. We detect some, we label some, and use that to auto-populate everything else. Then this kind of image segmentation came in quite well. Yeah, YOLO and so on actually perform quite differently comparatively. All right, any other questions? Thanks a lot for the question. Good one. Yeah. I see another one through direct question. How the algorithm work in Google Map when... Okay. The question is how the algorithm work using Google Map when there's a traffic jam and then they give another route, right? As suggestion. These are at least two problems you're solving. Okay, first is to spot the traffic jam, which I gave a simplistic approach where you can use clustering to spot how many, let's say, mobile devices or person reported the location they spend time in. And with that, you actually can calculate the number of people in the group, and that may indicate it's a traffic. Okay, this thing can be tricked easily. I remember there's a YouTube video showing one person that carry like maybe 50, 100 phone and walk slowly through the street and Google Map actually report there's also traffic there because of the person putting 100 phone in a trolley and walk across the street. That's probably another topic in tricking the system. But by spotting the location of all the mobile devices reporting the location, and they appear more than a certain density in a particular range, that already show traffic or may mean traffic. And the system now can actually decide and suggest if this is no longer the place you should pass by, you probably want to do a shortest route, but exclude the place that has traffic. There will be another algorithm doing the routing calculation, right? But then the best route that you can suggest based on the metrics like maybe distance, time, cost, then you can suggest to another person, right? And then that's how the person now get a route suggestion when there is a traffic. So there are a few steps the system is doing. First, understanding where you want to go, the route you are taking. Check any spot within this route has traffic that may not be meaningful to you because you may be spending more time in the traffic, and now suggest alternative that would have a certain metric to tell the cost of getting there is lower than the current one you are in. Then the study of that suggestion will come in. I'm not sure, does this explain better, right, to the person who asked this question? But why it is more confusing, because it's not a single step. You actually have multiple steps inside. When you combine these few insights that the system is telling you, you can then now take action to give, let's say, an alternative route. But it's a series of information the system calculated that allows the system to react. Yeah. So you can actually reply me, right, if you think my answer has answered your question.
Yeah, okay, Prof. So maybe this
Any
is
other questions that may come? Let me see. There's one answered. Okay, I think it's almost lunchtime, right? No, having hungry student in the class is not good.
Hello, sir. Hello, Prof. Am I audible?
Yes, sir.
Right. Then I'll hand the time back to Mr. Rico, maybe.
Okay, yeah. Thank you for Professor Sian Lund for the comprehensive presentation on clustering in data mining. So let me summarize some key points that covered today. So
I can't
the
hear
clustering. Am I audible, Prof? Prof, can you hear me? Am I audible? Yeah. Okay, so the key of the clustering methods is k-means clustering is most popular, use concentrate and the distance itself. We can already learn about Manhattan, Euclidean, and cosine similarity. And we also learned about the hierarchical clustering, like builds tree structures, bottom up, top down, and so on and so on. And then density base, like a DBScan, it's like a group base of the data density. And we also learned about the important concepts like clustering is an unsupervised learning, so there is no label needed. Use a similarity or the distance to group the data point itself. And we can use the clustering for the customer segmentation, traffic hotspot detections, and then the healthcare risk groups itself. And then the practical tips that we already learned from the Prof. Lund is use elbow method and silhouette analysis to find optimal number of cluster, or we can say like a key, and then a scale and normalize data before clustering. And then we need to handle the outlier and validate the result with the domain expert itself. So yeah, this session include our codes, examples, and emphasize the importance of the data preparations, evaluation metrics, and proper interpretation of the clustering result itself. So yeah, thank you so much, Prof, for the presentations. And now we will take some photos online. So I hope all students can open the camera.
Okay. For the students, kindly open your camera. I will take a photo. So if you are free enough, please open the camera.
Magisan. Ano ikut yang internasional?
Okay, there are several slides. I will take a photo one by one. Okay, now in 3, 2, 1. Next slides. Hang on, 3, 2, 1. I think that's it. Only 2 slides for the photo. And I will give up to Mr. Rico again. Thank you, Mr. Rico.
So yeah, once again, thank you for the Professor Shen Lund, and we can close these discussions for this session. Thank you so much, Paul and Prof.
Yeah, thank you. Yeah,
Thank you, Prof.
Thank you.
thank you.
Bye-bye.
Bye bye.